Okay, we're looking today at determinants and inverses. So for a determinant, it's a real number and it's associated with any square matrix. And it's going to look a little bit different. So it's got vertical bars, like right here at number one, instead of brackets that indicate that you need to find the determinant of this individual matrix. So to find the determinant, if we think of A, like matrix A as being A in row one, column one, B in row one, column two, C starting out row two, and then D, then to find the determinant of matrix A, we do A times D minus B times C. And what we're going to get for this is just a single answer. So for this first one, we're going to do 3 times negative 2. Then I'm going to subtract from that 5 times 1. So working that out, I get negative 6 minus 5, which gives me a negative 11, which would be my determinant for this number there, or for this matrix here. Next, I've got let's see. For my next one here, I've got negative 1, 4, negative 3, negative 2. So finding the determinant again, I would do negative 1 times negative 2 minus 4 times negative 3, which would get me positive 2 plus 12, I believe, to get me a determinant of 14. So anytime you've got those straight lines on a square matrix, you are finding that determinant. Okay, looking at inverses. So inverse would be more or less the opposite of. And so let's multiply these matrices out. So I've got both of them as 2 by 2s. So remember, we'll start out multiplying row 1 here times column 1 here. And do 1 and negative 5 times 11 and 2. Then I'm going to also multiply that by 5 and 1. So for the first one, I get 11 minus 10. And for the second one, I get 5 minus 5. So it'll be 1 and 0 there. So let's start out our answer. I have a 1 in the first spot and a 0 in the second spot. I'm going to do the same thing with the second row. So doing negative 2 and 11 times 11 and 2, and then times 5 and 1. So that gives me negative 22 plus 22 should be a 0. And negative 2 times 5 be a negative 10 plus 11 would give me 1. So 0 and 1. So that looks like we've had one or two that have ended up as that before. So when you've got something like this type of matrix would be called an identity matrix. And so if you've got the product of two squares, in other words, that are the same length and width or same rows by columns, um, the matrix is the identity matrix when you multiply those two together and get something like this. So when this happens, these are inverse matrices. So in other words, they're basically the exact opposite, or the the inverse of each other. So we will show that by saying like a to the negative first would read like, what is the inverse of matrix A? As it says, the identity matrix for anything has a diagonal of ones, and then the rest of them are zeros. And so you probably noticed if we multiply some of the things we multiplied out by, when we multiply by this, we end up getting the same numbers because it gives you the identity of whatever you're multiplying it by, or the same thing. So let's look at a couple of those on the back. So to determine whether these are inverses of each other, we're going to multiply A times B. So I'll shorten this a little bit. Do 5 times negative 3 gives me negative 15 plus 16. And I'll do 5 times negative 2, negative 10. 2 times 5 is 10, so negative 10 plus 10. Then I'm doing 8 times negative 3 gives me a negative 24. And negative 3 times 8 gives me a negative 24 again. And last but not least, I have 8 times negative 2 gives me a negative 16. And negative 3 times 5 gives me a negative 15. So this is the one that we really, numbers look like we want it to work out, but I end up getting a 1 and a 0 up top here, but then a negative 48 and a negative 31 on the bottom. So these would be, we're determining if they're inverses. Because we didn't get that identity matrix, we would say no, they're not inverses. So let's look at finding the inverse of a 2 by 2 matrix. So it says to find the inverse, we'll do 1 over the determinant times the matrix itself. And if we get an answer of 0 and we're finding that determinant, then that means we're going to have no answer whatsoever. So starting out here, let's find that determinant, which would be negative 9 times negative 3 gives me 27, positive 27. And then I'm subtracting 6 times 5, which is 30, which overall gives me a determinant of negative 3. So now what's going to happen is the inverse of that determinant would be 1 over that number. So 1 over negative 3. And we're going to multiply that by our matrix. Oh, by our matrix flipped over. Sorry, I almost did not get that part from us. So looking at our matrix here, we're flipping it and taking the negative. So A and D are going to switch. So that's negative 3, that's negative 9. And we're going to swap the 6 and the 5, or not swap them, sorry. We're going to make them negative. So -5, and -6. And then all I've got to do is multiply each one times the -1/3, and I will get that inverse. So 1/3, -1/3 times -3 gives me a +1. Then I have -5 there, so I end up with a +5/3. -1/3 times -6 gives me a 2, and then a 3. So after all that, what we have now is the inverse of this matrix here. If we were to multiply those all together, we should get that identity matrix, just like we got on the first one that we worked on the other side. So there are a couple other problems here that you can work out. Um, I should get, when we work out number 6, that it has no inverse. And then on number 7, you get one that has a couple of fractions with it. So that is your determinants and inverses when we are dealing with those square matrices.